Welcome to section 3.1, Exponential Functions and Laws of Exponents. This next chapter we're going to be getting into logarithms, but before we can do logarithms we need to talk about exponential functions because they're inverses of each other. So what we're going to do is we're going to graph exponential functions, and we're also going to apply laws of exponents and evaluate and simplify things. So the first thing is, what is an exponential function? An exponential function, f with a base a, is denoted as f of x equals a raised to the x power. So an exponential function, its independent variable is the exponent. But there's a couple stipulations. A must be greater than 0, which is important to know. And a cannot equal 1. And if you think about why can't a equal 1, well, 1 raised to a power over and over is just 1, so it's not exponential. And x can be any real number. Alright? And also this other one, a is greater than 0. If a was negative, think what would happen if you plugged in -2, for example, raised to the x power. It's going to be jumping back and forth. -2 to the first is -2, -2 to the second is 4, -2 to the third is -8, -2 to the fourth is 16. So it's going to be jumping back and forth, so that's not going to be exponential either. So that's why those stipulations are on there, which are going to be important for logarithms. A couple just quick questions to ask you in terms of using your calculator to do this stuff. If you have 3 raised to the square root of 2, now x can be any real number, so we can have irrational numbers up here like square root of 2, -pi. We can have rational such as 2/3. So let's take this and plug this into the calculator here. So the first one was 3 raised to the square root of 2. And I got an error. I don't know why. So 3 raised to the square root of 2. Very interesting. I don't know why that's not working. Let's try it this way. There we go. I don't know why I had to plug it like that in this calculator, but I did. So we got an answer of 4.7288. We're going to round to the nearest thousandths on this unit. So 4.729. So this is equal to 4.729. And then we'll go back and we'll plug in 5 raised to the -pi. And we got 0.006 on that one. And then 9 to the 2/3. And we got 4.327 if we round. 4.327. So those are, exponential expressions that we're looking at, and just, once again, just realizing that you can plug any value of x into those. Let's go ahead and look at the graphs of exponential functions. So we're going to start with the parent function, just like we did on all our functions that we've done before. So just to get you familiar with the parent function, if you're not already, let's just go ahead and do a t-chart. We'll plug in some negative numbers, 0 and some positives. Now, if you remember exponential, when you plug in a negative value, the number gets smaller. So this is actually 2 to the -2, which would be 1 over 2 squared, which is 1/4. If you plug in -1, you get 1/2. If you plug in 0, you get 1. Anything raised to 0 power is 1. 2 to the first is 2, 2 to the second is 4, and 2 to the third is 8. So this is kind of what our parent function looks like. Now, as x gets really small, these values get really, really close to the x-axis. And so kind of those, 5, probably these 5 would be the ones that we would be graphing as our parent function. So this is what 2 raised to the x power is equal to. And so we want to take that parent function and graph the rest of our exponential functions with base 2 using that parent function. So what happens, going back to transformations, when x is negative? Once again, think about this. If x is negative, then x is the negative is with the x, so the x is changing. Well, if x is changing, then what are we doing? Well, it's going this way, so that's reflecting over the y-axis. So this is a reflection over the y-axis. So we're going to take these parent function points again, and I'll graph negative 1, 0, 1, 2, and 3. So that's the parent function. And then I'm going to just switch colors here, and we're going to graph its reflection over the y. So this point would be over here, here. The one on the y-axis stays the same, and then over here. So our graph will look like that. A little bumpy there by the x-axis, but it's a little bit smoother than that, but you get the idea. So we can graph a lot of different exponential functions. Really, once again, just going back to the parent function and identifying what the parent function is and what transformations we're using. So I have 4 of them here. I'm not going to do all 4 of them, but let's just talk about the transformation. So you got 2 raised to the x, and then you have a plus 1. So that plus 1, remember, is changing the entire function, the y value. So this will get shifted up 1 unit. Alright, so once again, I'll graph the parent function, and that's just 2 to the x, and change color again, and we'll shift it up 1 unit. So now we have here just 1 unit up on all of these. Now here's the important thing, is that if you go back to our parent function, this graph gets close to the x-axis, but it never touches it. So we have a horizontal asymptote. So if we shift things up or down, that horizontal asymptote also has to shift as well. So we got to be careful when we graph these that on this one it got shifted up. So our new graph, try that one more time. Alright, it's now going to get close to the line y equals 1 and not the x-axis. So just make sure you're careful with that. On B, we got 2 raised to the x plus 1. So that is changing the x value, which means we are shifting 1 unit to the left, because it's x minus negative 1. So 1 unit to the left. So once again, I'll plot those parent function points again, those 5 points, and now we take each of these values and shift 1 to the left. And remember, if you ever are questioning whether you're doing this correct, you can always plug those values back in as to what you think they are and check to see if these points match your new function. And there you go. So let's just talk about the quick transformations of the other two, and then we'll kind of move on. The negative on this one is on the outside. It's negative the entire function. So the y value is changing. So once again, think y value is changing. So this means this is a reflection over the x-axis. And then on D, there's a couple things going on. Some of you might like to write it in this form and put the plus 3 on the end so you can see the shift up. But we have a couple things going on here. We have a shift up 3. You have the negative in front, so we just talked about that being a reflection over the x-axis. And then the minus 1 in the exponent means it's going to the right one. So you can do a couple things on each of these. Once again, really just going back to transformations like we've done. Okay, so the last part of what we're going to be doing today, because the first part was graphing the exponential functions. Now we want to apply the laws of exponents. So here are our properties of exponents, or laws of exponents that you've learned before. So let's just kind of run through them and make sure you write them down here. The first one here is when you take x raised to a times x raised to b, then you add the exponents. So if you look, the bases have to be the same. So when the bases are the same and you're multiplying, you add the exponents. When the bases are the same and you divide, you subtract the exponents. Also, negative exponents, those are your reciprocals. So x raised to the negative a is 1 over x to the a, and it can go the other way as well. Your powers of 0, anything raised to the 0 power is 1. And then you have your power of power. When you have something raised to another power, another exponent, x raised to the a, raised to the b, then you multiply those two. If you have a product of a power where there's multiple things going on inside, and each one of those is getting raised to the power of a. Same thing with a quotient. Multiple things inside, everything gets raised to that power of a. And if you have a fraction raised to a negative, you can go ahead and just use the reciprocal and say y over x raised to the positive a, and then you can rewrite it. And then on this last one, and be very careful of this last one, probably the newest one that you learned in Algebra 2, is that rational exponents. With rational exponents, a over b, alright, you can rewrite this as a radical. Now pay attention to where things are located. The denominator is your index. So if you have 1/2, then it'd be the square root. Alright. Now, also pay attention to the difference between the second and the third one. You can say x is being raised to the a value, alright, inside the radical, or if you want, you can actually put the a on the outside of the root of x there. So, quick example, x raised to the 2/3 is equivalent to the cube root of x squared, or we could write that as the cube root of x, and then we can square the whole thing. So that's what those properties are. These are the ones that you have learned before, and these are the ones we'll be using as well. So mostly at this point, I just want you guys to work through some problems. We're going to evaluate or simplify any of these expressions. So for example, on the first one, 625 raised to the 1/4. What is 625 raised to the 1/4? Well, you could always pull out your calculator and plug it in, and you would get the right answer. But what does this mean? You know, what is this that we're looking at? Well, what I just talked about. This is the 4th root of 625. So what's the 4th root of 625? Well, what raised to the 4th power gives you 625? And the answer is 5. Alright, and so once again, kind of going between radical and exponent as well. So 125 raised to the 2/3. Once again, you could plug this in to your calculator, but I'm going to have two parts to a test, a calculator and a non-calculator. So let's pretend we don't have the calculator at this point. This would represent the cube root of 125, and then we can put the square, we can put the 2 in two places. We can either put it down here. Well, I don't know what 125 squared is, so if I don't have a calculator, that's not going to work out very well. Or I can put the 2 over here. And so now, what's the cube root of 125? What times itself 3 times gives you 125? And that would be 5. So then you're left with 5 squared, which is 25. So a lot of times it's easier just to put the value of the a value on the outside so you can simplify it without a calculator. Let's go ahead and look at example C here. 3 to the 1/2 and 21 to the 1/2. They're different bases, so we can't, multiply and add their exponents. But what we can do is think about what this represents. This is the square root of 3 times the square root of 21. So if they're both the same in terms of the square root, we could do the square root of 63. And then simplify that now that we combined it into one radical. Square root of 63, the way I do these typically is find that perfect square, so it would be 9. That would leave us with 3 square roots of 7. Go ahead and move on to D. 25x raised to the 1/6, y to the 1/3. On this one, what we want to do is we want to simplify everything. We want the same denominator in terms of your exponents. So that's what we're going to do is we're going to rewrite y to the 1/3 as a denominator of 6, and that'd be 2/6. And so you have 25 x to the 1/6 and y to the 2/6. And let's go ahead and rewrite this as a radical. So we have 25 now the denominator, since we got them both to be the same, this is the 6th root of x to the first and y to the second. Alright, and so let me write that again there. That's 25, the 6th root of x to the first and y to the second. Okay. Try the same thing on e. Find a common denominator there. So it'd be 6 on this one. So it'd be 3 to the 3/6 times 2. You multiply these both by 2 to get the 6 on bottom. Be to the 2/6. So when we simplify that, we'll have the 6th root of 3 to the 3rd times 2 to the 2nd. Alright, so this will leave us with the 6th root of whatever that would be. I guess if you multiply, you get 27 times 4, and that would be 108. And so it's the 6th root of 108. And remember, to be able to simplify square roots, you have to have that certain group of, in this case, 6 of something. Over here, 6 of something. Square roots, you have to have 2 of something. Alright, what about the next one here? All of what's inside is being raised to the 2/3. So you have 5 to the 2/3, a to the 2/3, and then b to the 5/3. So since everything is being raised to the 3rd, we can rewrite it as the cube root of 5 squared, that's 25, a to the 2nd, and b to the 5th. Now, that's simplified in terms of changing it to a radical, but once again, if we have groups of 3 of things, then we can simplify it. Well, b to the 5th has more than, 3 or more, so we can actually simplify this. B to the 5th is b to the 3rd times b squared. So we can take one b out, and that leaves us with b times the cube root of 25a squared. And how many b's are left once you took 3 of them out? 2. And so that goes back underneath there. So that's simplified completely. Let's look at simplifying some of using our properties of exponents here, power property, thing like that. So on g, you have x to the negative 2 raised to the 3rd. You multiply the exponents. It's an exponent raised to another exponent. So you get x to the negative 6, and then another x to the negative 6. But now that you're multiplying, you add them. And since it's a negative exponent, you do the reciprocal. So it's 1 over x to the 12th power. And so I know I'm giving you a lot of different examples here, but there's a lot of things that you're going to be looking at in terms of your homework. So I'm just trying to give you a lot of different possibilities of what you would see. Let's do this one. We got 3 to the 3rd, that's 27. Y to the 9th, you multiply, because that's a power to a power. And then over here you got 27th y to the 3rd. And so when you multiply those two together, you get 729 y to the, this is a 3, so you add and get y to the 12th. So remember when to add, when to multiply those exponents is important. On the last one here on this slide, you got everything is being raised to the 3rd power, so it's 3 to the 3rd. And I'll expand this one out so you can see it. A to the 2nd to the 3rd. B to the negative 2nd to the 3rd. So what would that equal? 27, a to the 6th, b to the negative 6. But we have a negative exponent, so that would be 27 a to the 6th over b to the 6th, making sure you move that negative exponent. So there's 9 problems. I know that's a lot, but 9 problems to kind of go through and look at. And any of those you have questions on, please ask me in class. I'm going to go a little bit further here, not much though. Just look at a couple more here. Take a look at J, dealing with the negatives. This is division, so you can subtract. It'd be a 3 minus negative 3, so that's a to the 6th. B would be negative 2 minus 4, and that would be b to the negative 6. And C would be 5 minus 3, and that would be c to the 2nd. So once you simplify it, a to the 6th, c to the 2nd, over b to the 6th. Alright. Okay. Let's look at L here. So we're looking at the 4th root. So we're looking for groups of 4. So if you're not sure if 36 has any groups of 4, you're going to have to take 36 and you're going to have to break it up into its prime factorization. So 36 would be 4 and 9, 2 and 2, and 3 and 3. Do you have any groups of 4? No, the most you have is 2. So you're not going to be able to break up 36 in terms of the 4th root. But what about a to the 8th? Well, that's 36 times a to the 4th times a to the 4th. So yeah, there's 2 groups of a to the 4th. What about b to the 5th? Well, you got a b to the 4th and a b. So which ones can you simplify? Well, the 36 stays. The a to the 4th, there's 2 of them. So that's going to be a to the 2nd. And then a b to the 4th. You can take out one of those. And then, so what are you left with? Well, you're left with the 4th root of 36. And then the only thing that's left is a b. Now, you can kind of, as a, if you're looking at this, you can take 8 divided by 4 to give you 2 groups, and you can take 5 divided by 4 to give you 1 group with kind of that 1 left over, and that's what stays underneath there. So, alright, the last one I want to look at, I know I'm kind of going over here on time, but the last one I want to look at is this one. I want you actually to pause the video and I want you to try this one on your own. This is one that you will definitely see again. I mean, a lot of these are, but this one, we make mistakes on it because of order of operation. So try it on your own and see how you do. So this would represent 2 to the negative 2, so we have to do what's inside first. And so that would be 1/4 plus 1/9 raised to the negative 1. Well, we still have to add those, so we have to find a common denominator. So that would be 936 plus 436, which leaves me with 1336 still being raised to the negative 1, and then at that point you can switch them, 36 over 13. So make sure you take a look at that one and make sure you know how to do it. Really all of these, there's a lot of different problems I can give you guys on these. We'll talk more about this in class as well. Thank you.